Okay, so here's what we're going to do. We're going to do an example of finding the instantaneous velocity of this situation. So what's going on here? We have a spring that's attached to a weight, and this 0 point here is the beginning. That's our reference line. Okay, and so the position function of this block with respect to this line, this is what we would say the equilibrium point, where this block is modeled after this position function, which is sine t, because if you pull it down and let go of it, it's going to bounce, right, up and down, okay? And so this is a simple model that basically models that the position, okay? What we're going to do is we're going to estimate the velocity at 0. Okay, and how are we going to do that? Well, we're going to use a table of values and what we know about the difference quotient, right? So we know the difference quotient, Q, for this situation, because we're estimating velocity, is going to be S of t minus S of A over t minus A. And of course, A in this case is 0, so we'll put this as 0. Okay, and so if we estimate this, well, what do we get? We get S of t, which is sine t minus sine 0, oops, not sine theta, sine 0 over t. And so sine of 0 is 0, so what do we get? We get sine t over t. And that is the function we have to estimate. Okay? So now, so we'll put sine t over t here. And now this is where your calculator comes in handy. And you're just going to plug these values in and see what you get. So I'm just going to populate the values all the way down. So we get 0.998334. I'm not going to write out all the digits. Then we get 0.999983. And then we get 0. Okay. And now from the other side, we get the same values. Okay, and so what's this approaching as we get closer and closer to 0, right? So here we're getting closer to 0 from the top, from the negative direction, and from the positive direction as we get closer and closer to 0. Where is it approaching? It seems like it's approaching what? 1. And what are the units here? Let me look at here. So it says a lead weight on a spring is oscillating up and down. Its position at time t with respect to the fixed horizontal line given by S of t equals sine t says use a table of values to estimate v of 0. Okay? And it doesn't give us units. So I guess we're okay. So the velocity is 1. It could be centimeters per second, I don't know, millimeters per second, who knows. But the units, they aren't given, so we're okay. So the velocity seems to be approximately 1. Okay, so now let's use the derivative to check it. Okay, see if our estimate is right. So now we're going to use the definition of derivative. So velocity at 0, which is equal to s prime at 0, which is equal to the limit, right? As h approaches 0, or you know what? We're going to use the function. So it'll be as t approaches 0 of what? It's going to be sine t over t. Okay? Well, actually, let's just start with the original and show that it's going to be. So again, it's going to be sine t minus sine 0 over, not theta, over t minus 0. And of course, this is the same as the limit as t approaches 0 of sine t over t. And we know that the limit as t approaches 0 of sine t over t is 1, right? We've shown that before, right? This is the same as sine x over x as, the limit of sine x over x as x approaches 0. Same thing. So we know that the limit of this thing is 1. And so therefore, it verifies what we approximated it to be. And that's it. Have a great day.